We now find moment of inertia of a thin rod. Now let us imagine a rod represented by this rod is very thin. Now we have to find out moment of inertia of this rod about a perpendicular axis passing through the center of this rod. Let m is the mass of this rod, L is length of this rod, so therefore the mass per unit length, that is linear density of this rod, is m by L. This is the linear density. Mass per unit length. Now let us imagine elementary strip here of this rod. So let delta x be the width of this elementary strip and situated at a distance x from this axis. Now mass of width delta x will be m by L into delta x. This is the mass of the element, mass of this element. M by L is mass per unit length, so for dx length mass will be m by L into dx. Now moment of inertia of this strip is mass into square of distance, that is m by L delta x mass into the square of distance from the axis, so that is m by L x square delta x. Now to find out the moment of inertia of the whole lamina about this axis, we can imagine that this thin rod is made up of large number of such strips. Okay, now we can, this is L by 2, half of the length. We can integrate this equation from 0 to L by 2, so we will get the moment of inertia of half of the strip, and multiply by 2 we will get the moment of inertia of the whole strip, and multiply it by 2. So this is 2m by L. So integration of x square dx is x square plus 1 by 2 plus 1, 0 to L by 2, that is 2m by L. This is 3, just take 3 common, x cube, so put the upper limit first, it will be L by 2 cube minus, put the lower limit in place of x, 0 cube. So we can plot that I equal to 2m by 3L into L cube by 2 cubes are 8, 4, and this L and L cube cancel out L square, so ultimately it becomes 4 into 3 is 12, 1 by 12 m L square. Now this is moment of inertia of this thin strip about an axis passing through the center of this strip and perpendicular to the strip. Now if we want to find out moment of inertia of this strip about an axis passing through one end of this strip, okay, so then this is, we can apply theorem of parallel axis. We know the moment of inertia about this axis, so if we want to find out moment of inertia about this axis, let it be I dash. Okay, then applying theorem of parallel axis, I dash is equal to moment of inertia about this axis is ml square by 12. Okay, 4 into 3 is 12, so ml square by 12 plus the product of mass of this strip and square of distance between them. This distance is L by 2, so if we square it, L by 2 square, so we conclude that this is ml square by 4, so 12 ml square plus 3 ml square. So ml square by, so this will become 4 ml square by 12, that is I dash equal to 4 ml square by 12. So this is ml square by 3. So thus, by applying theorem of parallel axis, we can find out moment of inertia of this thin rod about an axis passing through one end of the strip.